We're going to talk about the transformations of cubic functions. So we want to do a quick reminder. The a value in the front, if it is a negative a, that's a reflection over the x-axis. After you deal with the negative, if a absolute value is greater than 1, it's a vertical stretch. If the absolute value of a is less than 1, it's a vertical compression. Remember this h value right here? If it's a negative h, it's going to the right. If it's a plus h, it's going to the left. And then our k value tells us whether to go up or down. If it's a plus k, it's going up. If it's a minus k, it's going down. So those are the transformations we've been doing all year. So let's start out by listing the transformations of our cubic function. So the first one, this 2 means there's a vertical stretch with a scale factor of 2. Plus 4, it's going to the left 4. And then this minus 4 in the back means it's going down 4. Just listing the transformations. Notice number 2. Now those are in a bit of a different order than we're used to. So I'm going to go ahead and rewrite that as 2x to the third plus 5. So the 2 is a vertical stretch, scale factor of 2, and the plus 5 is going up 5. Number 3, once again, it's not in the right order, so we can fix that. Negative 4/3 times x minus 2 cubed, and that's a positive 3, so I'll just move that to the back. So let's talk about the transformations. The negative means it's a reflection over the x-axis. The 4/3 is a vertical stretch because 4/3 is bigger than 1. Remember, once we take the negative off, we just look at the number. The minus 2 means it's going to the right 2 and then up 3. Now the next few are kind of interesting. We have an f of x function. A little bit of transformations have already happened. And then we have a g of x that's giving us some additional transformations. And they want us to write the equation. So let's think about what's going on here. In this equation, x minus 1 to the third power has moved to the right 1 space. And that plus 7 is going up 7. So that's where we started. Right 1, up 7. So right 1, up 7. Now in this problem, we are stretching by 2. So we're going to take what's already here, stretch it by 2. And then this is telling me to go down 4. So let's see if we can combine all that into one equation. G of x equals. Well, the a value is the vertical stretch of 2. Now let's look at the horizontal. The only horizontal move was this one to the right 1, so that didn't change. But this one was up 7, and then this one went down 4. So think about it. If I'm up here at 7, but I go down 4 spaces, I end up at plus 3. And there's my new equation based on the transformations they gave me. All right, this one has a few more things going on. So let's take a look. This one was reflected. It was stretched by 2. It went to the left 3 and up 1. So these things have already happened. It reflected. What does this one want to do? It wants us to reflect it again. So if I reflect it and then reflect it again, it's back to go, instead of this one going down, but if I flip this one over, now it's going up. So in other words, a negative times a negative is a positive. Well, this one doesn't have any vertical stretches, and this one does. So I still have a vertical stretch of 2. Now this one went to the left 3. Well, this one went to the left 3 more. So if I combine those, I have now gone to the left 6. This one went down 4, and this one had gone up 1. So if I start up 1 and then go down 4, I've actually gone down 3. So combining these together, I reflected and then reflected again. So I was going down, flipped it back to up. So that's a positive. I'm still stretching by 2. Remember, I was left 3 and then went left 3 more. So now I am left 6. Oh, that's a cubed. So plus 3, that's a plus 6. This is a plus 1, and then I went down 4, so now I'm at down 3. So if you look at each piece individually, -2 times -1 was 2, plus 3 was 6, plus 1 minus 4 was -3. Now we're just going to talk domain and range. Now notice this is a quadratic function. Our parent function looks like this. So here's the parent function. Domain, all real numbers. And what about the range? Well, if it's just the parent function that hasn't been transformed, the range started at 0 to infinity. Well, let's look at the next one. Notice that this one has been reflected. And where's the vertex? My vertex is at 3, 5. And it's going down. So the domain for this one is still all real numbers. It always was. The range for this one, because it was reflected, it's going from negative infinity up until this vertex point, which was the 5. And the third question, notice it is not being reflected. It has a vertex at -4, -1. It looks like this. Domain for quadratics is all real numbers. The range starts at the vertex and goes. So the vertex here was our -1. So -1 to infinity. Now in the second column, notice all of these are cubic functions. So remember what our cubic function looked like? Was the little kind of curvy guy here? So for the parent function, I picked that one first. The domain was all real numbers. The range was all real numbers. Is doing a transformation on this going to change the domain and range for us? Not at all. This one, even though it's a negative, that just changes it to going this way, to up, down instead of down, up. It's still all real numbers and all real numbers. Our cubic functions, the domain and range is always going to be all real numbers. This one, when we moved it to -4, -1, and we stretched it, but it just looks like that. Domain, all real numbers, which you could write with the capital R if you wanted to. And the range, all real numbers. So your cubic functions, the domain and range are both all real numbers every time. Look at this third column. This is an old one. We did absolute value a long time ago. Do you remember what that looked like? Those were the V's. So remember the domain was just like the quadratics, all real numbers, but the range went from 0 to infinity, unless there was some sort of translation, like this one. So notice it did not reflect, It just moved to the left and down. So if I go to the left and down 4, I'm still looking like that. So my domain is still going to be all real numbers, but my range changed a bit. Instead of 0 to infinity, where did this move down to? -4. So it's -4 to infinity. And the last one, notice it's a reflection and a stretch. We move to the right 3 and up 6. So let's see if I go over 3 and up 6, and then I'm going to reflect it. It's going to point this way. The domain for all of these absolute value problems is all real numbers. But because it reflected, the range has switched. It goes from the bottom up to this point. So negative infinity until this point, which was our up 6, to get our range.